For section 2.4, we're looking at using postulates and diagrams. So we're going to take some of our old postulates, have some new postulates, and then start seeing how we can evaluate diagrams as we go. Some ones we've learned so far back in the first chapter. First of all, we have the ruler postulate. This lets us measure segments. We can give them a value, we can give them a coordinate, and it lets us look at length, so we could actually label length. The segment addition postulate tells us that if we add up the parts, it's equal to the whole. So if I had a segment, A, B, C would be the parts, I could say that AB plus the length from B to C is equal to AC. Lets me add parts together. Protractor lets us measure angles. And just like the segment addition, the angle addition lets us add up angles as we go. So if we had angle addition, we could label here. I could say that the top angle, ABD, plus the measure of the bottom angle, DBC, is equal to the sum of both of them, or the whole thing, the measure of angle ABC. So we've used those back in the first chapter. They will still come up. Not so much in today's section, because we're more going to focus on some new postulates and utilizing them, but these are all very powerful postulates you will see throughout the year. Now, the new ones. So we have 7 that we're looking at. The first one is postulate 5, and we just continue with the numbering. Thing of note, you do not need to memorize the numbering to them. It's more just having an understanding of them. Your assignment today may ask for which postulate is it, which number. It's just better if you can recognize the name of what they say instead of getting stuck to a number. So through any 2 points, there is exactly one line. So 2 points, guarantee that I have one line. So if I have 2 points, then I have one line. I can't draw another line. It's not going to bend around. There's going to be one line through it. The next one is very similar. It says a line contains at least 2 points. So if I have a line, then it has at least 2 points. Now, it says at least. I could have more. I could actually have an infinite amount of points, but we don't usually think of that. It just guarantees that we have at least 2. So what those 2 actually say, I could start with 2 points and have one line, or I could have one line and that'll have at least 2 points. Related to each other, but it is really come down to the fact that a line will have 2 points. If we only have 1 point, it does not guarantee us a unique line. The next one says if 2 lines intersect, so 2 lines meet, then their intersection is exactly 1 point. So if 2 lines meet, they'll meet at a point. If they don't meet, well, they don't have an intersection or nothing in common, but intersection will be a point. They're not going to curve back and meet twice. They're not going to have an intersection of a line. 2 lines meet at a point. The next one says through any 3 non-collinear points. Now, before we go into that, non-collinear means they're not on the same line. These 2 points are collinear. So if we have 3 non-collinear points, then there exists exactly one plane. And those 3 points would all be on that plane. Now, we don't want to line them up because that would actually look like a book, and we could actually rotate planes around them. That's why it says non-collinear. So if we have 3 unique points, or 3 non-collinear points, we have a plane, and we can almost think of it like a triangle. Those 3 points need to make a triangle, and that will give us a plane. Next one, it's very related to postulate 8. It says a plane contains at least 3 non-collinear points. So if we had a plane, then it has at least 3 points on it. Why is it not 2? Well, that'd be a line. If it was just 1, it would be a point. So 3 points, kind of that triangle idea again, will guarantee that we have a plane. Now you won't typically see the triangle drawn there, but maybe it's some idea that will help you make that connection. Postulate 10 says if 2 points lie in a plane, then the line containing them lies in the plane. So here I have a plane and 2 points on there. If I have those 2 points on the plane, then that line going through them is also on the plane. So let's call this plane A, and these are points X and Y. So if X and Y are on plane A, then line XY is on plane A as well. Last one we have is if 2 planes intersect, then their intersection is a line. We've talked about this one a little bit in the last chapter when we first mentioned intersection. And if I have 2 planes meeting, they will meet on a line, and that would actually be this line in that case. So let's call this plane A, plane B, and line L. We could say plane A intersects plane B at line L. So those are the postulates that we have. Now, some are connected, some are kind of familiar, but we now have to take this information and we're going to start reading the diagrams to look for given information. Now, if it's not given to us, we can't use "it looks like it" as a reason. But if it's not given to us, we can't make a statement. So it's almost as if anytime we say something, we have to have a reason behind it. So we look at it. So we're looking if we can assume the following statements, true or false, by what we have in the diagram. I have line AD and BF intersect at H. So I have AD, BF. They do meet at a point. They should meet at a point. That was one of our postulates. That is point H. So that is true. AHF, which is this angle, BHD, which is this angle, are vertical angles. Well, vertical angles means they meet at that point, and they have opposite rays that form the sides, and they're on opposite sides of the vertex. So that one would be true. BF and CE intersect. So I have BF, I have CE, that's these two. It's these two lines. Now, they look like they could never intersect, they could go on. We haven't quite had the word parallel yet. That would be a good suggestion. But what this one really comes down to is we do not have a point in common. We have to have a point in common for them to be an intersection, so that makes it false. AD and BF are perpendicular, so that's this line and this line, or the measure is 90 degrees. Now, this is one that we can put into that "it looks like" category. Even though it looks like it, we do not have a box there indicating perpendicular, so that one is false. It's not enough information. They put a box there that's definitely true and we're good, but don't fall for that trick of "it looks like it." We can't do that in here. Next we have BHA and CJA. Now, what would make angles congruent? They would have the same measure, but we don't know the measure of these angles, so that's enough to say false. We just don't have enough information. AHB and BHD are a linear pair. Well, a linear pair we know is adjacent, so they share a side, share a vertex, and they're supplementary, which actually these are because they combine to give us a straight angle or a straight line. So although we don't know their measurement, we still know that they'd combine together to give us a straight angle or 180 degrees, so they are supplementary as well. We can say that one is true. BF and CE intersect, or do not intersect. Now, up here we said it's false that they don't intersect, or we said it's false that they do intersect. But we have to be careful because that doesn't necessarily guarantee that they do not intersect. This one is actually false. We do not know if they will ever intersect, and that's kind of a tricky part we have to look at. we haven't talked about the word parallel yet. If I called those parallel, it's correct, they would never intersect. We don't know it for sure, we do not have enough information, so right now it's false. G, F, and E are collinear. Here's another good one. I have these 3 points that line up. There is no line going through them, so since there's no line, we can't assume it, so it's false. All points shown are coplanar. In fact, all the points are on plane P, is the name we could give it, so that one is true. If we had a point off here somewhere, there'd be an issue there, but this one works. A, H, J, D are collinear. That's these 4. They are all on the same line, so that is true. Now, we have a new term we're going to work in here, and that is a line perpendicular to a plane if and only if the line intersects the plane at a point and is perpendicular to every line in the plane that intersects it at that point. So the line perpendicular to the plane is the line we're referring to here. Now it has to be perpendicular to any line that would intersect it that's on the plane. What I like to think about this one is it's like a flagpole. Probably have a flagpole out in front of the school. Now that flagpole is perpendicular to the ground. It's sticking straight up, and if we went around and measured, it would be 90-degree angles, really in any direction we go. So any line we put through there, it would also be perpendicular to. Even though this is not on the plane, we can still say it does give us perpendicular lines. So it's perpendicular to a plane if and only if it's perpendicular to all the lines that are on the plane that go through that point. Think flagpole. Okay, last one here. Some more practice. Maybe you want to pause the video, try these on your own, and then you can check your answer. But we're looking for the following statements cannot be assumed from the diagram. So we'll go on that kind of true-false approach. True-false. So A, B, F are collinear. I have A, B, F are all on the same line. That makes them collinear. So that one is true. E, B, D, though, even though maybe I could bring in a straight edge and they all line up, there is no line there. It is not enough, so that one would be false. Not enough information. They don't give us that. I can't just sit there and draw that line. We have to be given that information. Let's see. The segment AB is perpendicular to plane S. So we have AB, I have S. If we look, we have a little marking right here that says perpendicular. That is the key. That says it is perpendicular, so that would be true. Whereas CD, this line, perpendicular to plane T, which is more the vertical plane, that one we can't say is perpendicular because you don't have that box there. There's nothing there indicating it, so that would be false. Last one, we have AF intersects BC at point B. I have AF, I have BC. They should intersect at a point because they're 2 lines, and that point they meet at is point B. So that is true. They're asking for the not assumed. That is the first one, or the second one, and the fourth one cannot be assumed. The rest, we have enough information. Be careful as you go through these homework problems. Use the postulates. Think, do I have enough to say? You can't add stuff. It looks like it doesn't work. We have to have a reason or a marking or some indication behind it. It's kind of like if you're saying true or false, and then the question is asked why, you need to be able to defend that answer mathematically.